Let's see, we got my video here. That's good.
If you did that and did fantasy, right, at scale, yeah, that it'd be a matter of just popping up money into handle any unexpected penalties, but you win more often than you lose, you know, and you make a lot of money.
Yeah, so there's I could change them on there.
What you're talking about is the pay for play.
Like a FanDuel or something like that.
Yeah.
That's a different model than that, but I could. Because you have to, you basically, the setting, the best possible fantasy line, I mean, like, go straight to players that are open market, figure out
There you
Go
go.
into another area.
So I have my volume on right now.
Oh, okay.
All right.
Yeah, I hear you coming through my speakers.
Okay.
I don't have anything shared yet, but I see you.
Well, for those, ooh, yeah, there is an echo.
Yeah, let me turn on. Turn off my,
All right, we're gonna test it. Nope,
okay, all my volume.
test it. I just hear you in the background. Okay, but I don't think it's gonna pick up.
Oh, turn off my phone. No, phone.
Just give us a few minutes while we get the technical details set up. First hybrid meetup, I think that we've done.
Okay, turn on.
All right. Yep. I'm not hearing anything, so that's good.
It was going through my microphone.
Ah, interesting.
Okay.
All right. You want me to get going?
Yeah, why not?
I might as well.
Yeah, just make sure you share your thing.
Yeah, I'm going
And
to.
I'll double check it. If you see it on the screen here, that's what's going through, coming out on YouTube.
Sure. Okay, so I'm gonna go ahead and share my screen. Let me turn off Slack real quick. All right, and now we're live. So hello, people of YouTube. Be great if you guys were here in person, but this is our first ever hybrid meetup. With me today, it's Tim Spann. So Tim Spann and I have worked together for quite a while, actually. Tim was my solutions engineer when I was a customer, but we both have, the same similar interests into streaming technologies and how to get them to integrate. If you want to learn more about different things, Tim and I have actually done a previous meetup. So we did a webinar actually on Pulsar and NiFi being connected together. We did a recorded podcast that has a video associated with it, where we talk about using streaming technologies, essentially with customers. And then, of course, today we're talking about, a different part of the stack that, doesn't get enough love, I think, and that is our Cloudera has a product called SQL Stream Builder, which is actually built on Apache Flink. So I'm going to kind of show you a little bit of an overhead of what SQL Stream Builder is, and then I'll kind of go into what Apache Flink does as well, part of it to get an understanding. So Apache Flink is, in my opinion, is the de facto streaming analytics tool now. So there's been a couple different streaming analytics tools in this space, like Storm. I've used Storm, and if you've used Storm, then it's a bit of a headache. But Flink makes things a heck of a lot easier. They kind of looked at some of the space that existed with Apache Kafka and Spark, and each one kind of did some things relatively well, but fell short on others. And so Flink kind of noticed that there was this white space that was involved with that, and so they went after it. Well, Flink kind of works on a layered API approach. So you have a functional API, you then have the data streams API, and then you have the SQL API. So I'm going to jump ahead to the SQL API part, because that's essentially what we did. We acquired a company, last year called Aventador.io. And what we did is we made it very easy for you to do just SQL. And it actually packages up a Flink jar in the back end. And you're going to be able to download it for free today. So all of you should be able to download it. I want you to play with it. I want you to actually tell us what you think. I know you can't do that live, but on YouTube, there's definitely comments that I assume, Tim, that we're going to allow comments on the video. So there'll be comments that be allowed on the video. After we go through stuff, we'll be able to post the link in YouTube. We'll be able to post it in specific channels. Download it. Tell us what you think of it. So to give you an idea, Apache Flink is incredibly powerful, being able to do SQL against both streaming data and static data sets. So when you take a look at like some of the streaming tool sets out there, you have something like Apache Spark, which is really micro batching. So if there's latency or, the latency is a concern, SLAs are a concern, you don't really want to use Apache Spark as much. And Spark is really good at machine learning, and, it should pretty much stay in that wheelhouse. The other thing about Spark that's different is the sense that, you essentially have to kind of tweak and tune your memory consumption and all these different things. It's not very good operationally. Like there's a lot of operational overhead that could occur, especially when people are doing bad things, right? Broadcast joins within sets, you'll notice, there's data skew problems, and you'll run out of memory, and you have to know how much memory for drivers, how much memory for executors, all these different things. And then, you take like other tool sets like Kafka, there are things that have been built on Kafka for you to do joins of data sets. But the problem is that all that data needs to be a stream, and that's not necessarily true. I mean, think about it. I work with tons of customers in the streaming space, and one of the things that we talk about is the fact that, you essentially have real-time streaming data that comes in. Let's assume like you work for a telco, and you have error messages that are coming off of, say, like cable boxes, and maybe that data is being streamed in at a specific rate. And you want to then take that MAC address and join it to actually understand who's the customer, what's the premise, all this different information. To be able to join that in a stream, you usually pull that from a different table, like a customer table, right? And now you have essentially the streaming data set, and you have a data set that's not highly transactional, because customer tables typically aren't. And then you're just going to go ahead and bring them in so that you get a really good idea of that streaming record. And this allows you to make decisions much faster on that data set. The problem is that Flink, you need to really be a Java, Scala, and they do actually have a Python SDK, but you need to be a developer. And, the world is kind of moving. I mean, you look at like Chat GPT, right? Like that thing's amazing, but the world's moving away from, heavy development and moving into more data democratization. And that's kind of where SQL Stream Builder fits the mold. So what you'll see here, and I'm just kind of highlighting it, and I'm actually going to go through it and show it to you, is that you have a console, and this is a slightly older version of the console. The version I'm going to show you today is actually relatively new. But you're going to have this console. This console essentially makes you, or allows you, just to write SQL. You create virtual tables essentially in the backend, and you can connect to Kafka. You can connect to other data sources. And what Tim's going to show you today is that he actually connects to Pulsar from this, right, from the community edition, and is able to actually have, data coming in from Pulsar, and then do analytics on that data in real-time stream. But you notice that you're not really writing any code. I mean, I guess SQL is kind of code, right? SQL is a language, but you're not actually having to write the code in Java, package it up, and essentially go ahead and deploy that jar. You also have the capability to write advanced functions, and it gives you like a really good idea of what your data set looks like as the data is streaming. So you can actually have sample data rate. So this is kind of like an overall architecture of what it looks like in the back end. There's a lot of different pieces, but essentially you have this Squeal.io engine that's taking the data, and it also has the capability to have materialized views. So when you take a look at the way that this thing is kind of built for the Flink jobs, you'll be able to actually, grab the data in real time, and it's still using Yarn in the back end for Flink, but you can do Flink in multiple deployment models. I mean, this is obviously a container. Comparison between continuous SQL model versus the traditional model, essentially, nighttime batch, ETL, or even incremental batch, you essentially have a bounded stream, but being able to break out of that bounded stream is incredibly important. And so this allows you to go ahead and run with the continuous SQL. So I just wanted to kind of highlight what it was, and then I'm going to go through this. Now, the very first thing is we have this documentation. I'm going to show you this real quick. Let me move this thing on my screen here. But you're going to see that not only do we give you a way to download this as a Docker container, and you'll see that, if I bring up my Docker, it is actually running. If I go ahead and look at the containers, this is all of the containers that are running right now. So this is SQL Stream Builder itself. And, have all these different pieces part of the package. So not only do you get that, but you get some really cool tech with it. Again, we'll have the installation instructions on the YouTube, so you'll be able to download them, not a problem. But we also, we don't leave you hanging. So we'll also link the documentation on how to get started on creating a job. Now, this is what the console looks like. So if you come here, you'll see that I have just a normal SQL console. I have a series of virtual tables, and you'll see that the tables have where they came from. So we did create, a Pulsar connector. Tim actually built it out and has instructions on how to grab it. Want to caution you a little bit though, do not try to compile it in Java 8. I did, and I had problems. So make sure you compile it with Java 11. But this Pulsar connector is here, and Tim's going to go through that. I'm going to go through the different other pieces. But when you look at the series of connectors that come out of the box, we have data gen and faker. Give me one second. These allow you to actually kind of create data sets on the fly. You essentially can create an app that's built on faker, built on data gen, and then that allows you to go ahead and generate these data sets without having to do anything, and then you can start to query them. This way, you don't need to really have to branch outside of the container to do the things that you want. There's also change data capture capabilities, which uses Debezium in the backend, but that's for another day. We'll do a whole thing on that. There's also the idea of data providers. So there's data providers and catalogs. And with the data providers, it comes packaged with it, a local Kafka instance. The Pulsar instance, we're working on building something out with Pulsar. But with, so you have something in the back end to be able to generate tables on Kafka. And then the catalog. So it's very easy for you to register a catalog. You'll see here that there's different catalog types. Kudu, Hive, there's even a custom catalog. And what this does is it allows you to kind of tie direct in. So for people who are familiar with like Hive or Kudu, if you had a Hive database, when you actually go ahead and look at the tables, the virtual tables that exist, it actually lets you go through and look at all of the tables. It's connecting to the metastore itself. So you can see all of the tables that are there. You can see the DDLs of the tables. This makes it relatively easy when you want to go ahead and select data from them. You have a series of SQL jobs, and you can kind of name the job that you want. The jobs have unique IDs. What's really cool about these jobs is that if you go ahead and say, click on the job here, it'll actually fan out and it'll show you what the SQL is. Now down here, it allows you to go ahead and edit in the console. So it lets you bring the job back up. You can look at specific properties associated with it. So, how much parallelism, the sample counts, so things that exist. And then if there was logs associated with that job, you'll be able to take a look at the logs as well. So what we're going to do here is we're going to go ahead and edit this in console view. And you'll see here, I'm going to go ahead and load. When I execute this job down at the bottom, it's going to take anywhere from like 10 to probably 15 seconds. The job will start running, and then you'll start to see it pull. And this is generating data, right? So I'm insert into output table, select star from order. So if you look over here, orders has this faker. So this is actually just running essentially like fake data. And we're actually doing an insert statement into a JSON table, which if I come here and take a look at the described table format, you'll see that this is actually going to Kafka at the moment. But Tim's going to show you exactly how to do that at Pulsar. But this is actually inserting that data in real time. And we can get a little bit more granular. So if I go back to my SQL jobs history, you're going to see here that I have these views that are created. So let me go ahead and actually, before I do that, there's actually the creation of the view itself. So create view from summaries as select star from. We already have the summaries view created, but what you're seeing here is that, one of the benefits of Flink in comparison to other tool sets is windowing is incredibly easy. So here we're creating a view called summaries. We're going to go ahead and select the start window and start end, right? The window start and end. And so these are things that actually come out of the box. So the window start time, window end time, it's not something that we created. It's actually things that are happening in the back end, because once you create the window, the tumbling window in this case, Flink actually then has a start time and an end time so that it knows that the 20-second interval takes place. But that data actually becomes part of the data set itself. So we can select it, we can select the order statuses, and we're doing an aggregation right here. You'll see that we're doing an aggregation. So there's a count star, then there's a sum of the amount as total amount, and we're doing this over a 20-second interval in total. I don't need to bring this up because we've already created the view, but when I want to bring up this one, I'm going to go ahead and edit this in the console and load, and you're going to see that I now have select star from summaries, the jobs views over here. So let me go ahead and execute this job. And what you're going to see is you're just going to see one data set in the beginning. And then 20 seconds later, you're going to see another data set. And that's because we're just doing a select star from the actual view that we created. And remember that view that we created is there for, every 20-second increment. So let me see here. What do we got here? Job is running. There you go. So you'll see here, no one wants to see that their order status was canceled. Sorry about that. You're not getting your Christmas gifts this year, but sorry, Tim. It looks like we had 4 canceled orders come through. Total amount was $174. So I apologize. I was thinking big though for you. So, and you'll see now another one came in, but what we're doing here is we actually are able to do windowed functions, aggregations in the data set. This has a lot of implications if you're trying to play around with real-time streaming data sets. Now, the other thing, and we also have this capability to build a materialized view. So on this materialized view, I can go ahead and look at, so if I were to go ahead and inspect this data set itself, let me move this around. You're going to see the columns that I have: window start, window end, order status, order count, and total amount. So let's say that, 4 canceled orders stinks, but I would really like to go ahead and look at what happens when I have more than 4 orders. So we're going to take a look at a primary key, and that primary key we're going to say is status. So only the status that's canceled. I already built an API key, so that's fine. We're going to go ahead and add a new query into it. I have to move this this thing around a lot, so apologize for that. So we're going to say that we want this API key to be called canceled, or just cancel. We're going to select, why don't we select all the columns, because I want all of the data. However, what I want is I want to have a filter, and I want to add a rule. So I'm going to take the order count is greater than, and we'll say 4. I'm going to go ahead and hit apply. Now I have right here an actual API for me to go grab data. I'm going to go ahead and restart this data set. You can give it a minute. Once this data set restarts, now I'm going to start pulling samples. And give it a second. So while that's actually loading up, because it's taking a little bit of time, the other thing that I want to point out is the fact that you actually have the capability to build functions. So right now the functions are built in JavaScript, but you can pretty much build any function you want. So if there's something that you want to happen to the data, this function will actually happen to it before it goes to that table. So as you're saying, pulling the data in, you can have a function to convert one style of data to another, like gRPC. Like people always ask, can we do gRPC? And then I wanted to go to Avro. There's actually ways that you can do that in JavaScript. And so you can actually build a function to take in the gRPC data to convert it to Avro, and then everything else will be built in the backend. So relatively easy to do. If I come back to the console though, you'll see that I have a couple of things here. So I have one that's canceled, one preparing, one that's canceled 8. So if I come in here and I go ahead and I paste in that API, you're going to see that, oh, I have an error. So table view does not exist yet. Let me just do this.
Oh, you only have the word API in there, you don't have the full URL.
Yeah, I got it. There you go. So I think it's something with the materialized view in the back end, but this materialized view is actually only filtering out the specific data based on cancel, but it gives you that capability to go ahead and, create, views. This is really good for dashboarding. So for me, when I was a customer and I was building data sets, I worked for a water company, and we worried about pulling data off of real time on PLCs, and we worried about, truck routing, things like that. Imagine if we had the capability to go ahead and just push that data to an API key, and then someone could consume that and essentially put it up in a dashboard. That capability, to me, I mean, you're cutting out a lot of middlemen, right? You essentially can cut out microservices that are happening in that, you know, in between all of the pub sub capability, then the actual analytics that are happening, and then you have to move it to, say, another database, and then that database gets consistently refreshed. So being able to do that, incredibly important. Now, beyond that, there's a couple other key features, and then I'm going to pass this over to Tim, is that you have the capability to build a team. So in here, and obviously it's just a team of one right now because I'm running this in a Docker container, but if you decided to actually build this out or scale this out a little bit, and with the Docker container, there's obviously restrictions, but the cool thing is that you can actually take team members and invite them. And one thing that we're building in the product for the future is the capability to have everything backed in GitHub and have a project. So not only are you able to have a team, but you can have a project, a bunch of team members associated with said project, and then you can actually have it checked in and out of Git. This allows you to go ahead and create many streaming applications. You can have other teams that could have access, and then they can check them into their projects. So makes it much easier for portability and actually completes the full software development lifecycle. Last but not least, there's the Flink dashboard. So, I told you that SQL Stream Builder is essentially creating a Flink jar in the backend and actually running and deploying the job, and it's true. So if you come here and take a look at the running jobs list, so we have the insert that occurred, and then we have the views that occurred, and you'll see here that this views, it's actually broken down into the different stages, and there's parallelism. So if you look, you'll see that this is sending the bytes. This is actually doing a lot of the aggregations, and then this is then receiving. So if you come through, you can actually look at each individual detailed view. So you have a series of subtasks. You'll see here that I have a parallelism set of 1, but it also has the capability of watermarks. Now, why is this important? Well, there's two things in Flink that are incredibly important that I think are way different than the other streaming applications. Is out of the box, without you doing anything, it's actually doing checkpointing and actually maintaining watermarks for that data set. So the checkpointing, the default, and if you see here, you'll look here for checkpoints, you'll see the default configuration, and you'll see when the last time this data was checkpoint. So the default configuration for the checkpoints is 10 minutes. But what this allows you to do is like any kind of, like, let's say you're pulling off a Pulsar at a specific offset, and you know that you can handle an SLA with an RPO, like your recovery point objective is 5 minutes. You can set the checkpoint time intervals for 5 minutes so that if anything were to happen and the cluster were to go down, when it comes back up, you essentially go back to the last time that the checkpoint actually went. So there's a RocksDB engine in the backend, right? And what it's doing is everything in Flink stores things in memory, and that's why it's so fast. And then when it hits the checkpoint time, it checkpoints all the stuff down. It essentially checkpoints the offset, the record, all that information down into a RocksDB engine so that it's actually stored. Right? So now you actually have a stateful process that's occurring, and this allows you to go ahead and recover, wherever you left off. Now, if at the 4-minute mark, right, between two different checkpoints, you go ahead and drop, well, then it'll revert back to 4 minutes before and start to pull the data again from that offset. And this allows you to go ahead and make sure that you never have data loss. You might have to do a little bit of data duplication, so there becomes like a nice little play that occurs between the two, but you essentially, you don't have to worry about ever losing data. To do this with other streaming technologies, it's actually much more difficult. It's possible, but it's not out of the box. Like I did nothing. All I did was, you saw, I ran a job in SQL, and it automatically started checkpointing my data for me based upon, the default configurations. I can go in and tweak the default configurations, but you'll see here's all the checkpoints. I can get the history, when the last checkpoint occurred, the summary, and you'll see here the trigger time, last acknowledgement, end-to-end duration. So there's a lot of information that you get. I can look at the summary, and I can actually go ahead and here's the configuration of the actual checkpoint. So you'll see the interval of 10 minutes is the default, and it has a timeout interval of 1 minute. So very easy to go ahead. Now, from this, I can go in and cancel the job from Flink itself, or I can go ahead and stop the job from SQL Stream Builder. So you'll see here, if I go back to my SQL jobs, I've got views running. I'm going to go ahead and load this in the dashboard. And I'm going to stop the job. in the same regard now, if I go back, you'll see this job was canceled in the back end because I stopped it remotely. And so now I actually have, from an overview, I only have one job running and a series of completed jobs. So again, all of this together, you have Flink, SQL Stream Builder. It does come with a Postgres database as well, which is what the materialized views are built on. All this is kind of packaged up. Now it's a beefy Docker container, so make sure that you have time and internet. It definitely is rather large, but you essentially can build an end-to-end streaming application, just playing around with it without having to really leave Docker. And even Pulsar, there's a Docker container for Pulsar, but one of those things where you just make sure that you can get the two Docker containers to talk to each other. And that's something that we were working on earlier. So that's pretty much it from my end. I'm going to go ahead and stop sharing. So Tim, since it's me and you right now, buddy, any questions that you have?
Yeah, I mean, it's pretty awesome. I mean, I've been playing around with it for a little bit and it worked well with Pulsar. One thing I want to try out is joining maybe Pulsar and Kafka tables and then inserting the results somewhere. Some thoughts, and then stuff coming off those materialized views, using those, maybe pulling them in with NiFi.
Not a
Putting
bad
in
idea.
another topic. There's lots of interesting things that can happen. Where the pipeline starts, where it ends.
I mean, you could potentially, that could be a good bridge too, where you essentially are getting off of Kafka and pushing it into Pulsar. You can actually use it as a Pulsar sync, a Kafka source, Pulsar sync, have it consistently run. And then when it's time to deprecate, you essentially have another job ready to go that's pulling off, and it just cuts right over. So yeah,
There's some interesting things you could do.
might be something you could do. But right now, Tim is going to take control. Tim, you're probably going to turn your mic on. I'm going to mute mine.
Okay, we'll see how this works here. Hopefully everything's been okay. I've been checking on YouTube. Things are looking good. If not, we'll have the video recorded later. Let me get the shared screen going. I'm just gonna quick check the YouTube stream, see if everything looks good. I see my head there. I guess that's as good as we're gonna get. Audio should be pretty good. And we are here live in Princeton, New Jersey at TigerLabs in the storm of the century. So let's share a desktop. Hopefully everything is working here. I'm just gonna check on, I've got like 20 computers here. Oh, I just added another table on the fly because I'm like, well, it'd be cool if I had another table. Now, the thing is, because we're in a different location than where I normally run, my Pulsar is running on this laptop, so I had to go point to it. Something to think about. Make sure you have computer names and all that kind of stuff. I've got a couple of jobs running here. I love the names they give you here. My current one is Affectionate Curry, which is pretty funny name if you use the automated names. This one is pointing to data from City Bike. I'll let that run and then show some slides. Let me check that everything's coming through on the Zoom because it's going from here to there, going up on the screen so we can see it in person. Seems okay. I'm not going to waste time chesting around on that. So this is my talk is streaming data platform for cloud native event-driven applications because I couldn't make it any longer. And what did the welcomes? I'm Tim Spann, developer advocate of StreamNative. Been running meetups in Princeton for like 6 years, working at a bunch of different places. I worked with John over at Cloudera doing cool stuff with Flink and NiFi, and I still get to work with Flink and NiFi because we're all really good buddies, really good tech together. Every week I put out a newsletter that covers Flink, Pulsar, NiFi, Spark, Iceberg, Hootie, Delta Lake, all the cool tech out there in open source include tools, videos, the latest talks going around, updates to the projects, always something in there. Like I said, I work at StreamNative with some really cool people. David, who's maybe joining us if questions pop up. I don't know how interactive I made it. I'll see if there's people here have questions. David wrote the book on Pulsar. His is pretty cool to have around. Everybody together, when you're building stuff, it'd be nice if one box did everything, but the way it is right now, things change too fast and no one can be an expert in everything. So you really want to bring together the best companies, best projects together to work on things. So things like Flink, Spark, NiFi, Zeppelin, HTML, Spring, Python. And then what's nice is Pulsar can sit in the middle, talk to everybody, in and out, very easy to do. Simple demo, simple as possible. NiFi is producing messages into Pulsar. And then Flink is reading them with some SQL and we get some results. I have a specific example that I use for doing training people walking through, and maybe at a future meetup, if people are interested, I'll show you how to step-by-step build these flows from NiFi reading a feed of data. I'm going to read the city bike data in New York, set of JSON files, put that into Pulsar, then Flink will query it. Really simple. We have a number of connectors that work together. We've got a Pulsar connector to Flink that works with Cloudera, and we've got a certified one for NiFi. So if you've seen that new product that's based on NiFi that Pierre was showing today, you know, you could use Pulsar in that. And here's one that shows a really cool demo with all the product names in it. Very nice. I've got links to all the source code so you can easily get to it if you need to run something. The CSP-CE is that community edition that you could download from Cloudera with Docker. Run that, add Pulsar connector very easily. We show you how to do that. There may be some JDK issues. Make sure you're not running Java from the 1920s. You need a new one. You can also use Cloudera's Kafka Connect to connect to Pulsar via MQTT, and I did that when I was playing around. There's a lot of stuff that comes in that CSP, lots of fun stuff. And if you want to keep everything as simple and open source as possible, that bottom link is an example of using nothing but the open source projects, keeps it very simple, command line, boom, 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 NiFi, Pulsar, Flink, and you're done in 15 minutes building apps. You may not have heard of Pulsar if you're our friends from Cloudera. It is a project that's pretty impressive, the amount of people working on it, number of people using it, and how fast it's growing. It's one of the fastest growing streaming messaging engines. We surpassed Kafka maybe a year ago. They're pretty much done in the open source stuff they need to do other than bug fixes. We have a lot of growth to do because we got some new features in there. What's nice with Pulsar is one place to do messaging. So you do things you used to do with Rabbit, used to do with MQTT, used to do with Rocket MQ, JMS. We do all that. Word queues, any style messaging you want, and we support the Rabbit protocol, we support MQTT protocol, we support the Kafka protocol, support web sockets, we support REST, we support our own protocol, and it's open. So if you have another protocol you want to add, it's happened in the past where company needs it, the community comes together and builds it. You never lose a message, and what's unique with Pulsar is you can acknowledge messages and do that not in order. In other systems, you have to acknowledge in a group and you can't skip one. We can skip, go back, and we'll never get rid of that message as long as someone subscribed to it. Resilience, because we don't put everything in one giant heavy Kafka node, you can lose large parts of the system, never lose data and keep running because we separate compute and storage like you do in Kubernetes. So, and we also have a ledger-based writing system for the data. So again, very hard to lose data. Scale up to the level of Tencent and some of these other giant companies that are doing petabytes of data in a stream, thousands of nodes. There is no theoretical limit. Pulsar was created at Yahoo to be able to scale out a unified messaging system to any scale. So we got a Pulsar broker that does all the routing, make sure people get their messages. You know, we don't store much, we keep a little cache, automatically load balances, segments out topics, very scalable at as many nodes as you want. These can be very small, not very heavy nodes there. So you're not spending a lot in your cloud costs, or if you're running it on premise or you're running Kubernetes or Docker, bare metal, wherever. The secret sauce is we store everything in Apache Bookkeeper, which is a separate set of nodes. This is advanced segmented ledger storage that's very scalable, very solid, and it's a great way to store things. What's nice is it's built-in tiered storage. So you could automatically decide after a certain period of time, your data ages out to a S3 perhaps, or HDFS, and then you can automatically access that from any node. You don't have to run a process to pull that data back. It's always available. So I can roll back to the first message that ever came into a topic from any consumer, whether that's Flink. For Flink and SSB, I just gotta say earliest. And even if this is from 10 years ago and it's stored in S3, I could scale SSB to start querying from that first record. Obviously, that could be trillions of messages. So you might want to think about that and know how much you stored, or you might be in for a very long display. We keep the metadata outside of Pulsar or Bookkeeper, keep things straight. Everything is extensible. So if you want to add your own metadata storage engine, go for it. Originally, we were Zookeeper only, as everything else was a couple of years ago. But since everyone's embraced Kubernetes, we've added etcd and we've added RocksDB, so you could use those. Usually RocksDB is just used for standalone or developer edition, maybe just running in Docker on your laptop. So it doesn't give you too much overhead there. But most people, if they're running Kubernetes, you use etcd. Multi-tenant, so you could have one cluster support an entire company. In fact, there are companies out there that are hosting public Kafka and doing that on top of tenants within Pulsar. So you could have as many tenants as you need. They're all secure. They're all isolated. Great way to have one cluster support a lot of different organizations, a lot of different business units. Underneath there, as many namespaces as you need. And under each namespace, tens of thousands of topics, even 100,000. And there's work to make it even more per namespace. But 1 million topics is not unheard of within a Pulsar cluster, and that's just one. And we have built-in geo-replication, so I could go to the next cluster and keep them mixed. One could be in Google Cloud, one could be on-premise, one could be in AWS East, one could be in Azure West, and geo-replicate active all at the same time. All of them accessible from one thing, depending on how you want to do it. Everything to us is a message. We've got a value, your data payload that's binary. We got a key, so you know what you're doing. Keep some properties in there, just like Kafka. We keep your producer name, so we know who built your message, good for auditing. And we keep a sequence ID, so if you want your messages in order, you can do it. You don't have to, but you can. Names for stuff is pretty straightforward. What's really game-changing for Pulsar is any way I bring data into Pulsar, it doesn't matter how I take it out. So I could have Kafka push into Pulsar and read it on the other end as MQTT. And I could do all this simultaneously. So I could have 1,000 different producers going into one topic. They're all coming from different protocols. When it comes out the other end, you pick and match whatever protocol makes sense for you and match what kind of subscription type you want. So say I have SSB, I'm going to say maybe I want an exclusive consumer for that, and I'll use the Pulsar protocol, but I could also use Kafka protocol to do it. Or I could use the failover one. Now, if I want to do CDC, I could do key shared, put one key per table, and then have, like, you know, say 10,000 concurrent consumers all working on their individual tables. I could use shared to do work queues. So whoever gets the message gets it. We don't do ordering for that use case, but that's the case where I want to spin up, say, 100,000 small apps that consume the data as fast as possible and run some idempotent work on them. That's typical messaging use cases. And again, I could do both types of apps on the same time, on the same data, and not have any issues. They each get their own subscription. We track where you are on the server side. You don't have to manually handle that in the client like some other systems. We'll make sure you never get out of order. You won't lose a message. We have the ability to acknowledge individual messages and even skip some you might not want to process now. Do it in batch. Very flexible, very powerful way to do that. And those subscriptions just give you some impressive ways to decide how you want to use the data based on the system. Built-in schema registry, you don't have to connect to someone else's. If I put something in a Java bean, push it into a topic, I instantly have a schema. We support Avro, Protobuf, JSON, whatever you want to use there. It's extensible. And it's a very easy way to use schemas. And it works with Trino, Presto, Spark SQL, Flink SQL, whatever you want to use their regular clients, Java, Python, Go, pretty easy. Lots of ways to get your data in and out. And I show that with my kitten. MQTT is one way in and out. AMQP, which is rabbit, another one. Cat likes the rabbit one. Kafka is another one, which is cop, which I always think is funny. And then WebSocket's another good one. WebSocket's a really nice one for me doing demos. I can create a simple web page, points to a WebSocket. Doesn't look like I'm pointing to a messaging system. I just get a stream of data. And it's not a bolt-on. It's not a sidecar. It's not an add-on. It is a full protocol handler set at the exact same level as Pulsar. So when I say I support Kafka, I support it at the same level as Pulsar. So whenever I add one of these, it's a full set of protocol handlers, full set of library support. What's nice is once it gets into a Pulsar topic, it doesn't matter how it gets there. They're all treated the same. So I come in Pulsar, come out Kafka, doesn't matter, transparent to you. Same thing with all the other protocols, very easy. Now, we don't have our own streaming processing system like Flink or Spark does because we don't need to. We don't need to do Kafka streams, though we do support that through the Kafka interface. We have a very lightweight function system, very similar to say like a database trigger, not too heavyweight. You could do it in Java, Python, or Go. Java and Python are most common. And the brokers can run this code for you, or we can put it into Kubernetes. And you could apply on the fly different topics that will come in, and you could add new ones while it's running. You'll have to stop things. And anytime an event hits that topic, it'll automatically trigger that function. Good way to run some of your ML or make a REST call or do whatever you want. And then you could output to a default topic or to a new one on the fly using the built-in context system. Also gives you access to metrics, logs, all those sort of fun things you think there. Ecosystem's pretty strong. Here's a little bit of the things we support out there. I mentioned those protocols. There's pretty good client libraries for Node.js and for Rust and C++ and C# and Scala. And there's some other languages out there that are a little more obscure, but we support them as well. And then a lot of different connectors. So it's very easy to get your data in and out without doing any coding, and a lot of different ways to process your data. The connector we have with Cloudera is really solid. That works really well, and I'll show you that in the demo. You will get these slides. So I'm going through a little quick, show you how I connected to the SQL Stream Builder. David, who is going to answer questions if they come up. This is a link to his free book, which is everything you need to know on Pulsar. Full book available. Scan this, full PDF, nothing left out. Pretty cool. We just got added to the list of where to do real-time machine learning. Pulsar is a great place to do that. Got a link to a couple of articles, got a link to all my stuff, but let's hope that the demo did not crash and then I could get to the demo, because who wants to see slides? I don't really want to see slides, but you know, otherwise the meetup is too short if I don't have any slides. If you haven't seen NiFi before, this is the greatest day of your life then today. NiFi makes everything easy. Our friends at Cloudera have full support on it. Scales out as big as you need to. I've been using this so I don't have to write code for a long time. I'm using this to grab data from City Bike, which is a bicycle rental service in New York City. You could grab data from anything. There is sources for everything you could think of, which is pretty awesome. And it doesn't really matter. Get your data from wherever it is, comes in. I can convert it between different types, say XML or JSON, break records apart, add some things to the field. I'm adding a timestamp and a unique ID. And then I already sent that message to Pulsar while I was gabbing on. Again, I could change the type of this before I send it. Say I wanted to send Avro. I could have done that here with this simple command. I point to my topic. One thing you'll notice for Pulsar is the unique name of this topic. It might seem a little busier than you might see with Kafka or something else, because we have a couple pieces of information that are important. The first is persistent. We do not have to persist messages if it's some security reasons or some speed reason you don't want them persisted to disk. They can all be in memory till they go away. And that's perfectly reasonable. We can make messages expire. We also have the unique feature that you could schedule messages. So if you want them to run at a certain cron time or sometime in the future, well, send this message in 2 hours, or maybe run all your jobs, get all the messages into Pulsar topic, but have them designed to activate after a certain time, or maybe wait to 7 in the morning. So these topics trigger email, whatever you want to do. Then I've got my tenant namespace topic, get the data in there. Lots of properties to make things easier. I did not add a key in there. Pretty bad work on mine. Very easy to change things on the fly with NiFi though. So I'll add that key there and restart it. So the next round of data will have it. Not really too hard to do that. So now NiFi ran, it's sending data. I'm also going to go to another flow I have here. This one is doing all the weather in the United States. It's grabbing one giant XML file that's zipped up from NOAA, and I'm going to turn that into JSON files, and then I'm going to send that to Pulsar. Let me make sure I'm pointing to the right place. There's a couple different Pulsars here. Because when you move between places and you're running on your laptop, okay, that worked. As you can see, the awesome thing with NiFi, besides being able to stop and start, is that you get access to the provenance that told me what happened. Like here, I sent a message to this topic, and I can look at the content, see what I sent very easily. It's JSON now, it's not XML, and it's weather data. So I could see that in a query. I could see that other data in a query. Pretty straightforward. We'll pop over to SSB. I could see I still have a query running here. Now to connect between Pulsar and SSB is pretty straightforward. I don't want to get rid of my little running query here. So I'll show you the connectors. I just connected that Pulsar connector for all those different formats. Once I have it as a connector, I could go to the console and run a job to see what it was. If you look here, this is how I created my topic. Pretty easy. It's just a Flink table, point to my Pulsar ports, which there's one for REST interface and one for the binary, and say it's a Pulsar, say it's JSON, and point to the topic, and then I'll get my data out. I could also see all the query history that I've been running here, which is helpful if I forget how to run a query, which could happen. So this is running. What's nice is you can see behind the scenes. You can look right into the Flink dashboard and see how it converted that SQL. So this one is still running. So as new data comes in, it's going to show up in my query. I'm probably showing too many fields here, so I probably want to only show some of them. And IntelliSense works for most of the things. I could do maybe station status, and we'll restart that one. And I think I have another job running. We've got a couple in here. Let's send some data over there. I probably should trickle that data in from the interface instead of sending several thousand all at once. But, you know, once you get data and you can do it quickly, it's hard to slow that down. The one problem with streaming is streaming too fast. You blink, you miss that we were running a stream. So if I go back here, back in here, it finished running. And if we look at that, how many records that we got through, I just sent 1,700 records over to my Pulsar topic, and that went into SSB. And then we get new data down here. You can see I changed the fields, put the timestamp. Everyone can read Unix timestamps. You could tell I just ran that, right? Of course. I know John can. He's very smart. You know, it makes it a little weird. So from there, I could see everything running. I could go into my Pulsar manager and see the data's being read from the Flink Pulsar connector. This is my source code. It's got how you create the table, how to get the connector, and some examples of how we did that. There was a little gotchas in there, which we got to write out based on what version of Docker, or if you're doing it standalone, and where to get the connector. But I'll write that up a little more just so we have it. I have a little article here at Medium. I'll expand on that. What else can we do? I think we'll finish up the demo. Is there anything else I should show there? We see it running. We also create a materialized view really easily in SSB, which is a nice feature. Now it's a REST feed. I can read it again with NiFi or read it in with Pulsar. There's, you know, the circle of data can keep going. This cleaned up data can go somewhere else. There's a lot of power when you have NiFi, Pulsar, and Flink working together. It's like I said, it's the Stream Dream team here, man. This stuff works together really well, regardless of what data source, regardless of where it's going or what you want to happen in between. I'm going to quickly check Zoom to see if we have anything. Yeah, we can check YouTube. I don't want to bring that up on this, or it looks at the YouTube. I'm trying to look on my phone here. I'm going to check in with my colleague, David, who is on the line. I'm going to stop share for a minute. David, did you see any questions out there? Anything showing up on Twitter or LinkedIn or any of these fun places? We've got no questions in the audience. Got a very knowledgeable crowd here. This is one of the top universities in the world. So, you know, they knew this before I even did it. And then we had ChatGPT looking in here, and it already figured out what we were doing. It could actually write NiFi flows for us. And I posted that last week. I don't know if you see anything there, David. If not, you know, I think we'll maybe wrap it up a little early, and we'll take everyone out to one of the best bars around here, just so people can get some other stuff. Hopefully this rain doesn't turn into snow. So far, it looks just like continuous rain. But if there's no questions, I'm going to end this recording, and then I'll chop it up, make sure it looks nice, and I'll share a copy with Cloudera so they can add some bells and whistles, make sure they get all the links there. The links are in the meetup to download all the stuff. They're also in the GitHub, so you can get it. Again, it's pretty easy download, runs pretty well. Oh, I guess I didn't show you it running in Docker. I want to show you behind the scenes what this looks like. It's pretty straightforward. It's just a Docker compose, and it just does it for you. There's a lot running in there, but you get access to all the ports, so you can get into that. You could also get access to SMM, which is a cool tool to look at Kafka. I'm going to harass them to see if they want to do that to Pulsar at some point. We don't need it as much for Pulsar because there's not much you have to alert on. It just works, but still pretty cool. And let me stop that share. If I don't see anything, we'll end this. You could definitely ask questions through all the social media channels, through our Slack groups in the future. If you're seeing this recorded in the future, I hope the future is awesome and you're using Flink, NiFi, and Pulsar already. If not, ask some questions. I think we'll wrap it up. Any final words, people, John, or anyone here?
No, I think overall good demonstration, Tim. I appreciate it. Yeah, same thing that Tim said. If anyone has questions, you can always put them into the YouTube channel. We'll be looking at it for a little bit, and then we're going to also add those links should be able to add them into the YouTube when we get.
Yeah,
uploaded,
yeah.
So,
Like I said, we'll probably put up a clean version of this.
yeah,
With, I don't know, we'll add, everyone will have a weird hat on when we run it. It'll be magically AI'd, so everyone will be festive. It'll be great.
no, I think that's pretty much it. I think, again, once you download the community edition, let us know. Like, be great to find out what you like about it and what you don't, right? That's that way, maybe we can add some cool new features into the product. You never know.
Very cool. Well, thanks, everyone. I will probably be joining you next month for another meetup. We definitely got some conferences coming. Enjoy your holiday season. Hopefully, people have some time off. I'm taking some time off beginning of January, but there'll be more content coming. We'll make sure we get today's video and yesterday's video put out there in a clean format so you could see it. Thanks again. I am shutting down.
Thanks, guys. Great job.